Hi, in this SPSS micro lecture I will show you how to run a factor analysis in SPSS. So for this example I want to know if items that measure loneliness and items that measure aggression actually measure two distinct latent constructs. So I will run a factor analysis by going to Analyze, Dimension Reduction and click on Factor. I'm going to display variable names, and now I want to include the items that I'm interested in about loneliness and about aggression. So these together, 5 items and 9 items, are 14 items. Now first I want to have a look at the descriptives, the univariate descriptives, coefficients with significance levels, and the KMO and Bartlett's test of sphericity. My extraction method will be a factor analysis method, which will be principal axis factoring. I also want to see the scree plot next to the factor extraction based on an eigenvalue greater than 1. My rotation method will be an oblique method because I do assume that there might be some relationship between my two factors, so I will check for direct oblimin. If you have very good reasons to assume that there is no correlation between the factors that you expect, then you would go for an orthogonal option like Varimax. And finally, I'm going to check my options. I want my factor loading sorted by size, and I want to suppress small coefficients below 0.30. A more conservative method would be to say below 0.40. I'm going to paste this and then run this syntax. And here's my factor analysis. So first of all, in the descriptives table you can see the means and the standard deviations, and that we had a sample size of 816. In the correlation matrix we try to find clusters that tell something about distinct factors. So what we see here are the items about loneliness, the first 5 items about loneliness, and then here are the items, the 9 items about aggressiveness. Then here we also have the 5 items about loneliness and the 9 items about aggressiveness. So what I can see here already is that these items about loneliness, they correlate moderately to highly with each other. And if I look at these same 5 items, I can see that there are very weak correlations with the aggressiveness items. So here is a cluster of items that belong to each other, or at least it looks like they measure the same thing. Then we have the items about aggressiveness, and we can see a cluster of moderate to high correlations here as well. So it seems that these items also measure the same thing. So now I will have a look at the KMO Bartlett's test output. So the KMO, the Kaiser-Meyer-Olkel measure of sampling adequacy, should be higher than 0.5. In this case it's 0.904. This indicates that we have an adequate sample size for factor analysis, and of course we had a sample size of 816. So then I want to check the Bartlett's test of sphericity, which should be significant, and in our case it is. So this tests the null hypothesis that the correlation matrix that we just had a look at is similar to an identity matrix. So in an identity matrix, all diagonal elements are 1 and all off-diagonal elements are 0, which means there would be no correlations between items. We did see correlations between the items, and this Bartlett's test of sphericity also tells us the same, so we are safe to run our factor analysis. So now let's have a look at the table that tells us something about the total variance explained. What you can see here is that SPSS tries to, or at least extracts, as many factors as there are items. So we had 5 and 9 is 14 items that we included, so 14 factors are extracted. So now we will also check the number of factors with an eigenvalue above 1. And in this case there are 2 factors with an eigenvalue above 1. Together they explain 62.26% of the variance. And you can see that the first factor explains the most variance, 38.79, and the second factor explains 23.47% of the variance. Then we could also have a look at the extraction sums of squared loadings, and here you can see the variance explained as well. However, here it pertains to the common variance, and with the initial eigenvalues it pertains to all the variance that can be explained, and this is also the variance that we report in our papers. Then we can have a look at the scree plot. So if you look at the scree plot, you are interested in the point of inflection. We can see that this is the point of inflection in this example at 3 factors, and we count the number of factors before the point of inflection. So in this case, 2 factors, which resembles what we found in our table with eigenvalues. So there are 2 factors. We're not going to have a look at the factor matrix, the factor loadings in our factor matrix, because this is before rotation. We used an oblique rotation to make this factor matrix with factor loadings more interpretable. So we're going to have a look at the pattern matrix. And in the pattern matrix, you can already see that there are indeed 2 distinct factors, 2 latent constructs. The first factor measures aggressiveness. These are all the 9 items that pertain to aggressiveness. And then the second factor measures loneliness. So these are the 5 items that tell us something about loneliness. And then finally, we can have a look at the factor correlation matrix. And here we can see that our factors weakly correlate, but there is a correlation between the 2.